Good morning, guys and gals. It's Mrs. Frame, and we're getting ready to go over day 2's review. So get your review sheets out. And anytime you want to try something out first, you can stop the video, try it out, and then you can fast forward to see if you get the answer right. If you get it wrong, just back it up and see what you did wrong. Ready? Here we go. So we're going to start on this problem right here. Perform the indicated operation. First of all, I'm not asking you to factor. It says perform the indicated operation. We only do 4 operations in math. We subtract, we add, we multiply, and we divide. So in this problem, analyze here that we're subtracting a binomial minus a trinomial. So what we have to do is get them out of their parentheses and combine our like terms. So here we are going to distribute this positive 1, leaving us with 5xy plus 5z. Over here, though, we have a negative 1 that we have to distribute so that we can get this trinomial out of the quantity. So we're going to distribute that negative. Pardon me one moment. Okay, sorry about that. So we're going to distribute this negative 1 so that we can get these terms out of the parentheses. So negative times negative is a positive 5xy. Negative times positive is a negative 39z. And negative times negative is a positive 8. Alright, so now what we're going to do is we're going to combine our like terms. So I'm looking for my like terms. There's my xy's. I'm going to combine those coefficients and my z's. So I should have a trinomial answer when I'm done. 5 plus 5 is 10xy. 5z minus 39z, that's negative 34z. And then we have our constant, positive 8. That's it. Don't do anything else. Okay? Going to the next one here, this is a multiplication. So we are going to distribute. We're going to multiply the x in the binomial times everything in the trinomial. Come back and do the positive 8 times everything. And then combine like terms again. So we get 2x cubed minus 2x squared minus 3x. Now we're going to do the 8. So we have negative 8 times 2x squared. I'm going to line it up. Positive 8. That's positive 16x squared. I'm lining up my x squared so I can combine like terms. We're going to do 8 times negative 2x. That's negative 16x. And then 8 times negative 3, negative 24. Now what I'm going to do is I'm going to go ahead and combine my like terms here. We have 2x cubed. This is negative 2 plus 16 is positive 14x squared. Here we had negative 3 and negative 16. That's negative 19x minus 24. And folks, that is done. Last one over here is just a simple binomial times binomial. So you're going to distribute the 4x and then come back and distribute the negative 3 and combine like terms. We get 36x squared plus 8x. Come back and get the negative 27x. I'm going to line it up right here with the other x, and negative times positive is negative 6. Negative 6. Sorry about that. Negative 6. Now we just combine our x's. So 36x squared. Here we get 8 minus 27, negative 19x minus 6. And folks, it's done. Okay? Alright, moving on to the next section. We are going to work on our factoring problems. So we have these 4 problems here that we're going to look at. I'm going to grab my pen and move this stuff out of the way. Alright, here we go. We're going to start with this trinomial here. First we count. We see that they don't have anything in common. So we look at our count. 1, 2, 3. It's a trinomial. So the first thing we do is look at the front and the back to see if they're perfect squares. This is a perfect square, however the negative 10 is not. So we have to go with our guess and check method. So we're going to do our factors of a squared and our factors of 10. And then we're going to add right up the middle. So we were to choose 2 numbers that multiply to negative 10 and add up to negative 3. I believe negative 5 and positive 2 will be those versions. So we would do negative 3a when you negative 5a when you multiply these, and a positive 2a when you multiply these. And then when you add them up to the middle, you get negative 3a. So you're going to take your two groups and you're going to place them in the parentheses in the two binomials. You can multiply them back together if you wish to make sure you get back to the original problem. Okay? Problem number 2. Looking at these, first of all, these numbers are big. You want to see first if you can get something out of all of them. They do have a common factor. It is 2. So we're going to factor that 2 out. That leaves us with 7x squared minus, let's see, cut that in half, 37x, and plus 10. So that's a 7 right there. Clean that up. Alright, so we're going to do our 2 over here. We're going to do our factors of 7. We don't have a lot of choices. It's 7 and 1. And here we're going to do our factors of 10. Now we can do 2 and 5, or we can do 10 and 1. And I need a negative 37. And this is positive. That means that both of these must be negative when we multiply. Negative times negative is positive, but when we add them we get negative. And I'm thinking of my factors of 10. I'm trying to get to 37. I'm thinking 5 and 2 again. And if I multiply these, I get negative 35x and I get negative 2x. And when I add those together, I get negative 37x. Okay, now with these, when you have this lead coefficient here, the 7, you do have to be careful about placement. So once you find the two numbers that you want to partner, you need to make sure that you circle the opposite corners. So when you write out your answer, and this 2 has to come out, it's 2 times 7x minus 2 and x minus 5. Got to be really careful. If you want to multiply the 7x times a 5, you have to put them in opposite corners. And the negative 2 times the x right there. There's your answer. Moving on to this one here. You have to look first. They have nothing in common. So you go to the step 2, check, count their terms. There are 2 of them. So then you see, is it a difference of squares? And in this situation, yes it is. So you get x and x, a negative 7 and a positive 7, which gives you negative 7x. Positive 7x in the middle, and that cancels out. See, there's nothing in the middle. X minus 7, x plus 7. Okay, that's done. Next one over here. First we look to see if they have something in common, and they do. Taking that 4 out, that leaves you with y squared plus 9. Alright, so now we look to see at our factored terms here, y squared plus 9. So we have the capability to factor out the difference of squares or the sum or difference of cubes. This is the sum of squares. It is not factorable any further than this. That is all you can do. Right? Here we go. We have a cube here, and this happens to be a cube as well. This is the difference of cubes, and there's nothing we can take out factor at the beginning. So some things you can do to help yourself out are to actually write them in their cubed forms. So a cubed is a cubed, and 125 is 5 cubed. So then you're going to use your formula that I gave you, and what you do, remember, is you keep this sign, and then you change the sign, and then add. Keep the sign, change the sign, add. It's always a binomial times a trinomial when you have cubes. In this set of parentheses, you put only one of each of these terms, so a to the 1 and 5 to the 1. Okay? Here you put the other two a's, so a squared. In this middle here, what you do is you just multiply these two together, so 5a. And then here you put the 5 squared. So you have to put the rest of the 5 cubed. So 5 squared is 25. And that is it. You cannot factor this any further. This is a prime trinomial. Okay, here we have another perfect cube. First we look to see if they have anything in common, and they don't. So if you write them in their cubed form, 8 is 2 cubed, b cubed, and 27 is 3 cubed, and then c cubed. So again, remember what you do with first you place your signs. So you keep your sign, change your sign, add, keep, change, add. And then you just put one of each of these in here. So you're going to put a 2 and a B and a 3 and a C. Here you're going to put your other 2's. You have 2 squared, that's 4. And your other B's, that would be B squared. The middle, again, you just put these together. So 2 times 3 is 6, BC. And in this last spot, you just you put the rest of your 3's. So you have 3 here, you need the other 2 3's, so that's 9C squared. And that is done. Alright, next one here. Here's we have another trinomial, and their numbers are big. So first we're going to see if we can't factor something out. 25 and 40 have something in common, but they don't have something in common with 16. So we can't factor anything out. Now we're going to look at our trinomial, and we're going to look to see if the front ones and the back ones are perfect squares. And they are. So we're going to see if it's a perfect square trinomial. We're going to try 5y and 5y, and we're going to try 4 and 4. Now this is a negative, and this is a positive, this is a negative, which means these must be negative. Negative times negative is positive. Now we're going to multiply those, that gives us negative 20x. Multiply those, negative 20x, and that gives us negative 40x. So our answer is a perfect square trinomial is going to factor down to a quantity squared. And there's your answer there. Last one here, you have 4 terms. First you see if they have anything in common, and we see, oh, 3, 3, 3, not a 3. You don't have anything in common. So you group, cut in half, factor the front, factor the back. Here they have in common a 3x squared. If we factor out a 3x squared, we would get 3x minus 1. And if you're wondering where I got that one, you have to be able to multiply these back in, and they have to equal these top numbers here. So 3 times 3, 9. 3 times 1, 3. Over here on the side, you got to factor out that lead negative. We don't want that there. And then they have in common a 4, right? When I factor a negative 4 out of negative 12, I get 3x. When I factor a negative 4 out of positive 4, I get negative 1. Now you see what these two groups have in common. We cut it in half. We have our common group, which is 3x minus 1, and our leftovers 3x squared plus or minus 4, and there's your answer, 3x squared minus 4. And you can't factor that anymore because that's not a perfect square, so it's done. Okay, so there we have the factoring done. Now we just have left our rational expression. So let me clear and change the page here. And then we will move on. So here we have simplifying rational expressions right here. Okay, give you some advice. First, always when you're simplifying rational expressions, you must factor the numerator and the denominator. So we look at our numerator and we see that they have in common a 5. So we have x plus 5 in the top times 5. And in the bottom we have x plus 5. Alright, now we're going to simplify. We're going to cancel common polynomials. So we're going to cancel those out and replace them with 1. So we have 5 times 1 is 5 over 1, which is 5. Pretty simple, right? Over here, I'm going to give you some advice. You see that they're a lot alike, but this one's written backwards. You always want your y's to be your first term and your constants to be in the back. So we're going to rewrite it like this, and then take that negative with it, negative 2y positive 20. Again, you'll notice these don't quite match, but they almost do. If we factor this bottom, and remember, always factor that lead negative out as well, you're going to see something happen. We're going to take that negative 2 out, and that's going to leave us with negative 2 times y, and negative 2 times the negative 10 is positive 20. And now see what happened? We have our y minus 10s. They actually do match. We replace those with 1s, and we get 1 over negative 2, which is negative 1/2. There you go. It's not that bad. Now that you know how to simplify, let's continue. So we're going to the very last page, and we're looking at this one here. I'm not sure if your problem looks a little different than mine. If you have numbers in your numerator, just cross them out. Okay? when you're adding and subtracting, and you might want to put this on your note card, first you focus only on your denominator. So we're going to factor our denominators. So we have x and x, and then we have a negative 8 here that adds up to a positive 2. So I'm thinking of my factors a negative 8 that adds to 2. I'm thinking 4 and negative 2 will work. Okay, that gives me 4x and negative 2x. When I add them, it gives me what I want. So this will work. X plus 4 and x minus 2. Over here on this side, we have another one, and these are perfect squares. So I'm thinking this is going to factor very nicely to x plus 4 and x plus 4. All right? So now that we have factored, we're going to find our least common denominator, which is x plus 4, and that takes care of what they have in common, and then we need their other two as well, so the x minus 2 and the other x plus 4. And we'll change this in a minute, but right now let's leave it out the way it is. This term right here, this side, is missing the second x plus 4, so you would multiply the top and the bottom by the x plus 4. So I'm going to slide it in there. I'm no longer concerned with my denominators anyway. Looking at this denominator, this one's missing the x minus 2. So we would add the x minus 2 to the top and the bottom, or multiply them. Now they have the same denominator, so you would write that out with the same denominator. And I'm going to go ahead and write this x plus 4 quantity squared now, since there's 2 of them in each one, and the x plus minus 2. And in the numerator, we're gonna distribute and simplify. So we get 9x squared plus 36x, and then over here we get plus 3x squared minus 6x. Okay? And now all we have to do is combine our like terms in our numerator and see if we can simplify that. So here we get 9 plus 3, that's 12x squared, and then 36 minus 6 is positive 30x over our denominator, which is x plus 4 quantity squared, and then x minus 2. And then in our numerator, you see if you can simplify it. In your numerator, you can see on your next step to factor out your numerator. In common, they have a 2 and an x. So if we take a 2x out, we would be left with 6x plus 15. I guess we could have gone bigger than that. I guess we could have taken a 3 out of both of those. So let's go back and try that again. Let's take a 3 out. A 3 would give us, I think, even bigger, a 6. Yes, a 6. Let's try 6x. That leaves us 2x plus 5. Hang on sorry about that, guys. Alright, and so that's what we get when we factor our numerator. All over x plus 4 quantity squared, x minus 2. Either of these answers is actually correct, because when we factored the numerator, there wasn't anything in our denominator that we could cancel. So I would accept this answer or this one. That was probably the hardest question on the test. Here we go. This next one here, we have the same issue, but it's a lot easier. Make sure you pay attention to this negative here. It goes right there. Okay, your least common denominator is simple to find. There's no factoring. It's just xy. This factor, this fraction's missing the y, so we're going to multiply times y. And this one here is missing the x, so we're going to multiply the x. Now they have the same denominator of xy, so we just write our numerator. We just write it out, 3y minus 2x. There's nothing to factor out in our numerators, and our denominator we can't cancel, and so that one is just one and done. Alright, last two problems. Here we go. I just gotta scooch this up real quick. And I may have changed these problems a little bit. So if mine are a little bit different than yours, just stop and change yours so they look like mine. And notice that I made a change here as well. Okay? And then press play when you're ready. Okay, so here we go. When you're multiplying and dividing, the rules are totally different. You're supposed to factor every part, numerator and denominator, and simplify. So we're looking at this one here, our 3x minus 4, nothing factors out of that. We look at this here, and this will factor. We've got x and x, and our factors of 4 that add up to 5, I believe 4 and 1 will work. Yes, 4x and 1x give you 5x. So this would factor to x plus 4 and x plus 1. Over here in this numerator, we can factor this out. That would give us 4 times x plus 4. And then down here we have to factor as well. Here we have the factors of 3, so that's 3x and 1x. And over here we have the factors of 4. So we can either use 2 and 2, or we can use 4 and 1, or 1 and 4. We're trying to equal negative 1. I'm going to choose 1 and negative 4. Now this is why. Because that equals 3x and that equals negative 4x. And when you add those together, you get negative x. And so now that I found my partners, the numbers I want to multiply, I'm going to, because I have a lead coefficient, I'm going to cross circle my partners here. And this one's going to be 3x minus 4 and x plus 1. Right, so I'm going to rewrite the whole problem. We have 3x minus 4 on the top, x plus 4, and x plus 1 in the bottom, times 4 times x plus 4, and then over 3x minus 4, x plus 1. And now that we're multiplying, it's the same old thing that we always do when we multiply. You're going to cancel your polynomials. So we have 3x minus 4. You can cancel diagonally, guys, and you can cancel vertically. So we can also cancel the x plus 4, and actually there's nothing else we can cancel. Even though there's 2 of these in the bottom, it's a horizontal and you can't cancel horizontally. So your leftovers 4 in the numerator and your denominator, x plus 1, quantity squared, because there are 2 of them. There's your answer. Okay? Last one here. I changed it up just a little bit, and remember when you divide that you keep this the same and then you multiply this and you flip the reciprocal here. So you're going to keep it, change to multiplication, and write the reciprocal. Keep, change, flip. So we're going to keep that the same, and we're going to factor as we go. These have in common an a, so I'm going to factor out an a, and that's a plus b. And we're multiplying now. Okay, and we're going to flip these over and we're going to factor. So this one on the top, it factored out. That's a difference of squares, a minus b, a plus b. But I'm going to flip these around, so I would write that down here because I'm doing division. Okay, and then on down here in the bottom, these have in common an a and a b. So that's a b. That's what they have in common, and that leaves me with a plus 1. So ab times a plus 1. Now we're going to cancel all the likes. So we can cancel here and here. We can also cancel these monomials, this a and that a. They're monomials, so we can. And then there's nothing else we have in common. So your final answer would be b times a plus 1 all over a minus b and a plus b. And that's just a sample. Okay? So I would write down the steps for all the different types of rational expressions. And you have them in your notes, so copy them onto your card and make sure you factor carefully. Good luck. See you tomorrow. Bye.